Hello, everybody. Welcome to the webinar today. We're going to be talking about the real world use of MQTT in a brownfield manufacturing environment. With me, I have Frank Costa from Sandalwood Engineering and Ergonomics. Frank, if you don't mind, give a quick introduction to yourself and Sandalwood, and then we'll get started.
Yeah, thanks, Tim. Frank Costa, I'm a manager at Sandalwood here in the system integrations group. I've been with the company 20 years, focusing a lot on data acquisition. The company itself helps tier ones and OEMs in health and safety engineering, and again in IT solutions and services.
All right. Let me switch modes here, and we'll go ahead and get started. So, Frank, tell us a little bit about the brownfield challenges that are out there.
Sure. If you're in the industry, you've probably seen this, right? Manufacturing, existing facilities, the infrastructure just wasn't designed with connectivity in mind. So, plants rely on legacy protocols and siloed systems they were never designed again to have IT involvement. So this creates a lot of roadblocks for scaling and digital innovation. Um, so when we're going through, there's always that push and pull um, for a total overhaul versus a retrofit. Uh, and that's kind of why we're having the discussions today to show how you don't have to tear everything down, right? And how MQTT um, and the right platform can allow you to fulfill that digital transformation of your plant in a cost-effective manner, and most importantly, without a risk to operations.
And I mean, most of the companies that we go to have at least some element of brownfield challenges, right? Even companies that have modern equipment, there's some part of the plant that usually has, some sort of aged equipment that doesn't necessarily have established connectivity and so forth.
Yeah, and that's we're talking proprietary formats, things. You and I have both been in plants where they're still running presses and equipment from the 50s. So that to get information out of them, it's a technical challenge, and you don't want to go through and go down the path of using a proprietary system. Um, yeah, for sure.
Yeah. So then, why does MQTT work so well in these brownfield environments?
Uh, there's a couple of reasons, right? It's open source, so you can at the price point you want to be, you can use something like a Mosquito right off the shelf to go through and implement all the way up to fully enterprise and corporate supported systems like a HiveMQ, right? It's a lightweight pub sub protocol. Uh, it decouples the data producers from the consumers, and it's just excellent in unreliable low bandwidth networks. And more importantly, it scales automatically, so it'll support um, a gradual rollout strategy. For those of you that maybe aren't as familiar with MQTT and what PubSub is, um, I like to use the analogy of mailboxes. So when you're in terms like MQTT broker, that's kind of like the post office. It's a central hub, and all mails or messages goes through that post office. Um, when we talk about MQTT publishers, those are like the senders. So when you write a letter and put it in a mailbox, you are the sender. You don't have to know who will receive that letter. You just kind of give it an address and send it. And in MQTT, a device like a sensor or a PLC will publish that data on a specific topic or address. So if the publishers are like the senders, an MQTT or a subscriber to MQTT are basically the recipients, right? You have a mailbox at home, you go through and check the mail. You really don't care who's sent you the mail, only that it's addressed to your mailbox. So, uh, using that analogy, an MQTT, an application or device, subscribes to a specific topic or address to receive the messages that are published to that topic. Um, and the beauty of MQTT and MQTT topics, instead of having like a single address for one person, you can think of it as um, these topics are like categories for mailboxes. So you might send, I don't know, your all your bills to the bill mailbox, your friends letters to the friends mailbox, or the subscriptions to magazines to another one. The senders put the mail into those specific boxes, and the recipients only get the mail that from the boxes they're subscribed to. So again, when looking at that, um, the what makes it good, MQTT being a lightweight pub sub messaging protocol, uh, it's exactly, it sort of matches what you need. It decouples, like I said, the data producers from the consumers, and allows multiple devices to publish when things change, all to maybe that the same topic or mailbox, or to separate ones.
Okay.
Oh, I did want to throw one more thing in there, Tim. The
Yes.
security. Security essential. We're going to touch on this hopefully later on, but everybody wants to harden their footprint, and MQTT is inherently secure. It supports TLS encryption, certificate-based authentication, and top-level access. So, um, yeah, just want to make sure that that's thrown out there.
Okay. I like the mailbox analogy. So um, I run my business, out of my home address. And so, I get both my business mail as well as my personal mail coming to my mailbox. And it's like both of those can come in, but they kind of get sorted as they come in there. And I get separate piles for, my work versus my personal. So yeah, I like that. Makes
Yeah,
it
for
easy to understand.
Yeah, so all whatever data you want can always be published to a broker. But if you only care about, using your analogy, right, the bills, I don't know
Yep.
anybody who really just cares about the bills. That's You would subscribe just to that subsection of your mailbox, and you just pull those in, and that's all you'd be exposed to, and not have to worry about all the rest.
Well, I would care about more than the bills, but the spot in the mailbox for checks is disturbingly empty all the time.
Well,
But hey, electronic payments are wonderful also.
sure.
All right. So MQTT sounds like it's a great solution for brownfield environments. But if you could talk a little bit more about some of the key benefits of MQTT adoption, that would be great.
Sure. A big one is, it reduces that network load, right? So, traditional legacy architectures, a lot of them worked on polling, right? So you sit there, has something changed, has something changed, has something changed. That's chatty, and that creates a lot of network traffic. Uh, MQTT is event driven, so data, when you're using MQTT, data is only sent when it changes. So I'll think I can illustrate that in the second slide. But it greatly reduces not only the network load, but the load at the device, collecting all that information as well. Um, Another benefit of it is its scalability.
Mhm.
Because MQTT is a pub sub model, it makes it super easy to scale. There isn't a huge setup to go through and create a new topic. The publisher of the data, be it your sensor, your PLC, whatever, all it does is say, I'm going to send information to this broker, and I'm going to do it on this topic. And you can create topics at will, and they push the proper area in the broker itself without any configuration. What this also does too is greatly improve data reliability. So if you're using, and I think we could talk about it later, right? When you're using a store and forward capability at the edge, that means data isn't lost during a network outage. It can be queued up and it can be resent once connectivity is restored. Um, Again, because it's so lightweight and it is open source, it's really low cost of expansion. So you can scale with brokers uh, relatively quickly, and you don't have to go through and replace PLC or heavy. Your infrastructure costing is a lot less because it works as a retrofit. You can, as you deploy, you can run your traditional or legacy system in tandem um, with this new MQTT infrastructure, and just you're sending data to your one system, and then you start publishing data to the broker. It allows for basically a gradual modernization instead of a huge full costly upgrade. Uh, Another one of these is real-time visibility. Using the broker, as we sort of mentioned, you're publishing data and their system that subscribes to it. There are a plethora of tools that can actually go through and subscribe to the same pipes your systems are receiving them on, uh, to actually visualize what's coming up. And we can talk about the merging of the MQTT pub sub protocol along with what we call a UNS. We'll get into that, and that gives you a huge amount of visibility into actually the data that's actually being sent up. Another great thing is it's not proprietary. All the standards, you might hear things like Sparkplug B, these are all open standards, but you can, yeah, the data payload inside an MQTT message is infinitely scalable. You can drop in, doesn't work very good for streaming, let's say a video, but if you're going in and dropping in um, JSON documents, PDF files for transfer, it all works the same. And this is what I talk about when you start decoupling your data infrastructure from any sort of single hardware or software vendor.
Right.
Again, it's all open, so you can go through and do what you need to do. And there's a couple.
But the chunks can be really big, basically.
Absolutely, absolutely, absolutely. And again, there's two more points, or a couple more points, right? This is the basic technology and infrastructure that a lot of the big cloud producers or cloud systems use, right? They're using MQTT on their back end to go through and facilitate the data transfer from your shop floor up into the cloud. And basically what we're doing here is bringing that all on-prem as well. So you can make that decision as a company if you do want to keep everything internal to your own network or start leveraging some of the power of, let's say, Azure or AWS or GCP.
Okay.
And again, it is UNS. I don't know if UNS is tailor made for MQTT or MQTT is tailor made for UNS, but we'll get into it. And just the whole concept of UNS and standardizing your data footprint, just in and of itself, lends, it's just incredible how much more productive you can be.
Okay. I don't know if you'll get into this in a different area, and if so, just let me know. But from a brownfield environment point of view, you've got that stamping machine from the 1940s out on the floor. And rather than retrofit it with a new PLC and so forth, the ability to just put a couple sensors out there that talk MQTT and be able to pretty much instantly get that information is a huge benefit, right?
Yeah, absolutely. A lot of the new IoT sensors come with the ability to publish to an MQTT broker baked in. They might They might come with other protocols as well. Modbus is nice and open, but it doesn't have all the features um, that a more newer protocol has. But I have not seen, if you see IoT attached to a sensor, you're going to go see MQTT attached to it, or ability to publish JSON. It's all the same thing.
Okay.
So, and just going over one of the, I just wanted to go through and show a slide real quick. One of the benefits I talked to you about was that network infrastructure, and you can go through. It's hard to come up with numbers, but using a traditional polling as a baseline at 100%, the event-driven messaging that is used in MQTT, just it vastly reduces the overhead. If you're going through and let's say you're trying to get a temperature sensor, picking up the data, you might be setting a poll rate of a second or 25 milliseconds just to make sure you're capturing everything. When you're using MQTT or event-based, the machine sends, or the sensor sends out the data on change. So you might not see a change for 3 hours. Why am I going through and trying to get that reading every second or every 25 milliseconds? It just sends it on change, and again, greatly reduces both processing and network load. I wanted to highlight that.
Yeah, I think that as much as the network load matters, it also, as you say, matters at the server, because if you've got 100 different devices out on the shop floor, or 500, or however many, if you're doing that polling on a frequent basis and you're having the server have to generate that polling, both sending and looking for the response, that's a heavy load on that server just to do that polling, let alone processing the messages that come in and then doing something with it. If you're doing it on the push basis, when you're only pushing something to the server when something changes, first of all, there's not a message going out and a message coming in. So that cuts it in half right there. And
Yep.
then, when machines are down or not running or whatever, you don't have to worry about that because there's no change. So it doesn't come in. So I can definitely understand the changes between those two charts right there.
Sure.
Um, let's see. So if you're looking to transition and move to uh, MQTT infrastructure, what's the plan?
Yeah. So there's varying plans out there. We've used a 7-step, a 6-step, but they all kind of boil down to the same sort of thing. The first thing you want to do, especially in a brownfield site, is assess what you got out there on the floor. Identify the current systems, the protocols, and more importantly, those critical components, so you can understand what you want to work on first, right? Um, Part of any sort of MQTT deployment, we talked about network load and processing. You basically want to introduce the edge. So they're hardware components that sit closer to the equipment, and they're actually going to be doing a lot of the data capture, the data pre-processing, and then they're going to go through and publish to a broker, so that data is normalized closer at the edge, and you're not doing that heavy lifting over on the server side. So once you've assessed your architecture, you introduce your edge hardware, you want to go through and actually set up an MQTT broker. That could be, again, sitting on a edge device as well, or some other different level hardware, and you want to go ahead and enable that engine. So you want to start subscribing right to the edge, subscribe to the broker, your endpoint, subscribe to the broker as well. So you create that connection. Once you have that, you want to start mapping your actual tags. So your equipment you've got out there, you want to start mapping that tag to information that you want to publish. And this is where step 5 and step 6, they sort of go together. Step 6 is just very important. Build that UNS. That is, plan out what, organize your topics with a consistent, scalable naming structure. Some places use snake case. I want to get into a little bit more UNS on the next slide. But the idea is start taking the data from the floor, map it onto a unified namespace, and then you start publishing the data. And then the 7th one is you migrate your analytics. So you might be using a proprietary front end right now to interrogate the data that was coming up from your floor. This is where you can move to that newer platform or start developing slowly, transition those KPIs and those dashboards over to consuming the data from the MQTT broker. And it should be fairly straightforward, because if you build your UNS correctly, then that complexity is greatly reduced.
Okay. So you've been talking a lot about UNS. I think this is the transition point to where we give you a little bit more detail about that and how it fits into this whole architecture.
Yeah, and if you're in this webinar, or you've been going through this digital transformation journey, you must have heard about UNS. And it's really straightforward. It's a hierarchy. It's a real-time structured data architecture that allows users to organize and integrate all the data across the manufacturing floor. So it's literally just planning out how you want planning out this hierarchy. So it allows you to focus on structure, work on a single source of truth. So every station that you're sending data from would adhere to, in this example, we've got enterprise site, area, line, asset. So no matter where you're looking at it, you know what that architecture is. And then the next level would be a data type, where you could instantiate information, like grouping your information in, and then finally the data that you send over. It's architecting this UNS and thinking about planning out not just for your legacy asset information, but for other data sources as well. If you have it fall into the structure as it transmits data, that means your SCADA system will read the data the same way as your MES and your ERP. And data exchanges between the two, if they adhere to the UNS structure, can be identified. So you start getting away from one of the big issues with legacy systems, those siloed data, because now your SCADA understands what your ERP is saying, which understands what your quality system is saying. And it basically, again, at the edge, you're taking your multiple different protocols and you're bringing it down into one cohesive common language structured in this unified namespace. I think if I can go through it just visually to show, we like showing this, right? So you've got your edge, which is this common transport layer. And again, it sits as close to the device as you can. So you have your asset data might be talking OPC DA, MT Connect, Modbus, whatever those protocols are. You've got sensors that could be talking over Ethernet, TCP. Other systems might be interacting with either a REST API or other protocols. So you've got the edge that is consuming all these different, as it should have the ability to consume all these different protocols, but it is going through instantiating that information into a UNS and publishing out that nice structured, common, open message over to the broker. And then at that point, once it lands in your broker, you can have your different system either consume, in this example, I've got SCADA just looking straight at the broker for live data and consume the information direct, or you can, again, push it to a data lake in that uniform structure, and then it can be accessed from any number of systems, and they all talk the same way, which means those systems, if you have your filling out a quality form, you are a quality check, and you write it back to the system, you can use a UNS structure to send it back to the data lake or publish it, and it can be displayed directly on your SCADA system because the information looks the same in UNS, and we're servicing the data in the same format. Is that making sense? What I'm saying? I'm trying to go through and show like the power of how powerful this could be.
Yeah, absolutely. For me, having that broker there helps. It makes sense to me, especially in a brownfield environment where you've got kind of a mix of different sources, and the MQTT is one source that's feeding into that, but it's a source that's really easy to set up and configure and connect some of those things that wouldn't otherwise have an OPC connection into that data broker and so forth.
Yeah, for sure. And again, that key is going to be using that edge to instantiate that UNS and transform the data. So a high byte would fit into that. Ignition edge would fit into that. Kepware, PTC Kepware. Those are the types of things that you want to deploy at the edge.
Okay.
And yeah.
So let's talk a little bit more about in this brownfield environment, you're making this transition. What needs to change, and what are the things that can kind of stay the same?
Yeah. So and that's, again, we talked about ease of use and going over, right? So you're looking at a traditional PLC. Let's talk about that. Your logic doesn't change at all. Your existing SQL databases, NoSQL historians, they don't change. Any current OPC UA or DA server, that's not going to change. You can leave them the same. The UI screens, so we're talking the front ends. It's going to depend on what platform you're using. If you're using a proprietary platform, if it can ingest MQTT, great. If not, there's going to have to be some decisions going on there. And the actual historical collection of data, you're probably going to have to rebind to the new data source. And for this example, I'm going to use Ignition, which has both an edge and a front end component there too, right? So if we were doing Ignition, the UI screens really wouldn't have to change. You just have to update some of the tag bindings, and the same thing for the tag historian and the alarms. Just rebind them to the new incoming tags. The things that you would definitely have to add, and we mentioned it here, you'd have to add the edge gateway and device, right? And program it as such to consume the data and then instantiate that UNS. And then the addition of a broker. And again, you can do the in-house, I'm going to start with Mosquito, which you can download, open source, free to use, all that stuff. And again, as you scale, if you start finding this isn't doing it for me, or I want to have more control at the enterprise level, that's where you can upgrade to. And again, I've used HiveMQ as an example, or Chariot from SiriusLink. You don't change the configuration. If you give it the same address, everything is already pointed to your named Mosquito instance. You can go through and just throw in a different MQTT broker, and it'll still work. Again, or you can have them publish data to two separate brokers, and that's how you can scale. And then again, on the adoption of the UNS, it depends on the platform you're using. Using the Ignition model, it would be probably updating your UDTs. And then once you do that, they'll update it across your footprint.
Okay. So let's make this a little bit more real. Can you walk through an actual example of a conversion?
Sure. So we worked at it wasn't a huge site. It was a small manufacturing shop, but they had numerous devices on their network that were running Modbus or the old Modbus AEG processors. So in that instance, they were all wired up with Bluehost, and they were all talking to a central server that had one of those old serial to Ethernet converters built in, and they were pumping that information into a proprietary SCADA front end. So we took a look at them. They were worried about the costs and whatnot. So what we went through and did is we actually, the old legacy system kept running, and we brought in the same thing we talked about. We assessed it. We brought in an edge device. In this case, it was a Linux-based one, and we used an edge product to go in there and consume the messages. We did have to go in and get I believe it was an MGate serial Modbus to Modbus TCP. We started collecting the data at the edge and working with them. We went ahead and created. It was a very basic UNS because they were in the process of updating the other systems. But we went in there and helped them establish what that looked like, and then we just started publishing that data over to a broker, where that data was consumed by a front end, which the particular platform that we had Historian built in, and we did a couple other functions on the front end. But all that information was available at the broker, so they could actually go through and see. And they had a couple smart guys on their staff that dabbled in a little bit of web development. So not only were they consuming the information on this front end we built for them, they were feeding their own web services, all from that broker, all from that single source of truth. And we left. They just were continuing developing on that platform as they took training and whatnot. But it definitely pushing everything. Modbus is open, but they could go through and see, if we were expanding, this is how we'd add these devices to the edge. And that's all they really had to worry about, because then Edge would just publish out to the broker. So they saw the value of the open standards. Again, the discussions as they were adding new equipment, the concern about adding different flavors of equipment kind of went away because it was easy to scale. We actually, their old system, I don't know if anybody remembers 98. It was running a 98 air-gapped PC just because that's how old the drivers were. So, so, and what we did was we pushed the processing back down to the edge. So, yes, they had to get a server, but they didn't have to invest a ton of money into doing that, right? It was just the server infrastructure they put in was ingest the data and write to a database, right? So it wasn't a huge dollar value, and they saw a much better ROI for their costs. They talked about cloud readiness. They weren't ready to go to the cloud yet because there's costs associated with it. But they saw how this kind of set them up for if they ever move to that point. And again, I talked about the scalability, the flexibility, and the cost effectiveness already. They are no longer fearful of bringing in additional equipment and additional inputs of data into their SCADA infrastructure, because they know it's going to work. We set up the front end so it automatically, things self-subscribe to MQTT as they become through Sparkplug B, excuse me. As soon as they're available at the broker, everything self-subscribes, and it creates the screens that are required, the historical points that are required, and KPI calculations dynamically as new data is added. So super helpful.
Okay. How's this for a transition? You mentioned being fearful. Early in the presentation, you talked about cybersecurity and how this can help with your strengthening your cybersecurity within the plant. Can you talk a little bit more about that?
Yeah, I think we're coming up to time, so I'm going to run through it. But MQTT inherently it can be configured to be secure, and it's not just on the protocol, but it's also on the broker software that you use, right? So it supports. We talked about TLS certification right out of the box. if you're using, for example, Mosquito, go to the Mosquito config, set it, and the settings are right there. Access controls are supported, again, through an ACL file. The free Mosquito supports it, as do things like EMQX, I believe it is, and HiveMQ. And one of the big things is you can minimize that attack vector. So you can keep that broker right behind a firewall DMZ, and you only have to harden maybe that broker. So everything can sort of talk to it, and that's a part you don't have to worry about hardening your entire floor. You just have that one attack vector you have to harden, right? So you can put in the proper firewalls and whatnot in there. So you're not exposing. With the introduction of MQTT, you don't have to expose the whole network. There's just that one piece that you got to protect.
Yep. Okay. What are some of you talked about, the transition plan earlier. Just cover, kind of in summary, what the major steps are for evolving the shop floor data infrastructure.
Sure. And we talked about that last example, right?
Yeah.
There's a couple things. Everybody wants these huge rollout plans. We got phased, and we're going to do. Everyone tries to boil the ocean all at once. Don't wait for that perfect infrastructure. If you want to move down that path to modernization, MQTT is the way to go. And you got to start somewhere, right? So don't wait for that perfect infrastructure. See what you have, and then again, layer that modern technology on it. One of the biggest things is, will I lose my data while we're doing the transition? There is a clear path to how you keep operations running while you're going through and deploying it. And MQTT is the perfect way to do that, because again, as I've highlighted, everything's open, so you can go through and work on these implementations in parallel. The big thing, though, which is very different from legacy systems, older systems that were very proprietary, the inherent open nature of MQTT allows these digital transformations to actually focus on the people as much as the technology. So getting the end users involved, the supporting staff is super important, right? So the investment on that end can really help accelerate the digital transformation that's being prompted by MQTT.
Yep. All right. Any final thoughts? We don't have any questions in the chat, so anything to wrap up with?
Okay. No, I mean, if you've been going through and doing this, the keywords UNS, MQTT, Edge. That's it. Just if you're looking at it, do those research in those areas. They're not hard concepts, but they are powerful ones.
Yep. And I'll say keyword Sandalwood. Reach out if you have any questions, and there's email, phone number, website here. The QR code will take you to the website, I'm pretty sure. So everyone, please reach out if you have questions. Frank, as always, thank you for joining, and see you next time.
All right. Thanks, Tim.
All right. All right.